In today's class, I am going to start a chapter, 11th standard CBSE chapter, Redox Reaction. In this chapter, Redox Reaction, in a chemical reaction, two substances are participating. One undergoes oxidation, another undergoes reduction. This chapter name itself is Redox Reaction, means one substance undergoes oxidation, another substance undergoes reduction. How this takes place means, if you take a simple example, sodium react with chlorine to give sodium chloride. Here sodium becomes, in the oxidation number is 0, here oxidation number is +1. This undergoes, we say, oxidation. Whereas this chlorine is in oxidation number 0 and it becomes -1 here. Therefore, we say it is reduction. Oxidation is a process in which an atom or ion loses electrons. Na plus 1 electron. Or sometimes if you take Fe gives rise to Fe2 plus 2 electrons. Fe2 plus undergoes oxidation to give Fe3 plus 1 electron. These three processes are called as oxidation. Whereas another reduction process is Cl plus 1 electron gives rise to Cl minus. Here another substance, oxygen plus 2 electrons gives rise to O minus 2. In oxidation process, an atom or ion loses electrons. In reduction process, an atom or ion, here two atoms, ion means Fe3 plus 1 electron gives rise to Fe2 plus. So this is reduction process. These three are oxidation process. Here an atom or ion loses electrons, whereas in reduction an atom gains electron, Cl gains 1 electron becomes Cl minus, oxygen gains 2 electrons and becomes O minus 2, Fe3 plus gains 1 electron gives rise to Fe2 plus. These two processes are, one is oxidation and reduction, whereas in this chemical reaction, both these reactions are taking place simultaneously. Sodium undergoes oxidation, chlorine undergoes reduction. Such a simultaneous oxidation and reduction process is called as redox reaction. Redox reaction. In this chapter, I am going to define one term which is oxidation number. Oxidation number. Oxidation number means it is charge possessed by an atom of an element. Like in sodium chloride, Na has plus charge, Cl has minus 1. Sodium has oxidation number +1, Cl has oxidation number -1. Therefore, it is a charge possessed by an atom of element in a compound is called as oxidation number. Sodium has oxidation number +1, chlorine has oxidation number -1. So there are some rules to assign oxidation number in compounds. Rules to assign oxidation number in compounds. First rule is hydrogen has always oxidation number +1 in its compounds, but there is an exception. In metal hydrides, hydrogen has oxidation number -1. In second rule is oxygen has always oxidation number -2 in its compounds, but there is an exception. This oxygen has oxidation number -1 in peroxides. In H2O2, oxygen has oxidation number -1. And also there is an exception. In F2O, oxygen has oxidation number +2. These are the two rules. First, hydrogen has always oxidation number +1 in its compound, but one exception is there. In metal hydrides, hydrogen has -1. The second rule is oxygen has always oxidation number -2 in its compounds. In H2O2 it is -1, in F2O these two are exceptions. For example, in water oxidation number of oxygen is -2 only. In any compound, in glucose C6H12O6, here also oxidation number is -2. And the third rule is first group elements in the periodic table has oxidation number +1 in its compounds, and second group elements in its compounds it is +2. For example, CaCl2, here NaCl, first group elements have oxidation number +1, whereas second group elements have oxidation number +2. And fifth rule is sum of the oxidation numbers of atoms of elements in a neutral molecule is 0. In a neutral molecule. For example, CH4, oxidation number of X is X, carbon is X, plus 4 hydrogen, 4 plus 1 is equal to 0. X plus 4 is equal to 0. X is equal to -4. This sum of the oxidation numbers of this carbon and hydrogen is 0. That is why we are calculated X is equal to -4. For example, in CO2, sum of the oxidation number of carbon is taken as X, only one atom is there, and oxygen is 2 minus 2 is equal to 0. X minus 4 is equal to 0. Here X is equal to +4.